Coming to the final talk of our session, I'd like to invite Manuela from Swiss TPH to give us another modelling talk. Yes, modelling.
Hello, good morning, everyone. Just a slight shift in the perspective now, as I'm not talking about genomics at all, but I'm talking about simulating the impact of interventions at district level and the implication of this mathematical model for decision making. Okay, sorry. So, as you might know, the one-fit-size-all approach is not appropriate anymore, and strategic plan needs to be tailored at local level, as the impact of intervention varies at the scale. So this complicates the decision-making process, and the aim of my PhD work is to develop a modeling framework to support decision-making and to generate evidence for decision-making. We are collaborating with the National Malaria Control Program in Tanzania, and to provide modeling support for stratification of interventions and to update the next malaria strategic plan up to 2020. The questions raised were to simulate the impact of the interventions planned in the strategic plan and to assess whether the aim of a prevalence lower than 1% at national level in 2020 can be achieved, and further to understand the relative impact of additional interventions at each district. But before I go further into the methods and the process, I would like to give you a brief overview of malaria in Tanzania. So malaria is endemic throughout the whole country, and it decreased from roughly about 30% in 2000 to 9% in 2012. And in recent years, it increased from 9% to 14%. However, this increase was not everywhere, as malaria is highly heterogeneous at subnational levels. So in some districts, there was an increase, in some a decrease. And this highly heterogeneity you can also see on the map on the right. It's malaria prevalence according to microscopy from the latest malaria indicator survey. And there you can see the seasonal trends, as malaria is unstable but seasonal in the central plateau. It's here mostly in green. Malaria is stable and seasonal in some northern and southern parts, and it's most intense around the lake zone and southern coastal parts. So now back to the method and to the project. So we're trying to simulate, or we're simulating the impact of future interventions, and we're using Open Malaria. It's a mathematical model developed by the Swiss Tropical and Public Health Institute, and it takes several factors of malaria into account, as you can see there. So for transmission, it takes into account the entomological inoculation rate, and if this is not available, it can be estimated by the prevalence. Then it's important to know the number of cases cured. This can be estimated by the effective treatment coverage. Then there's also seasonality, which we estimated by, or we used rainfall as a proxy for the seasonal trends. And it takes also into account the historical interventions. So what kind of interventions are deployed at which coverage, at what timing? So there we considered indoor residual spraying and net ITNs. And then the most difficult part is the entomology. The model accounts for different vector populations, for different biting behaviors and resistance. So we assumed 3 vector populations, Funestus, arabiensis, and Gambiasis, with varying biting behavior and varying resistance against parasites. So taking this data, or this modeling approach, we organized workshops with the National Malaria Control Program in Tanzania to discuss the questions and we have to discuss the assumptions and data available, how the model is best to be calibrated, and finally, early next year, we will present final results. So throughout the workshop and throughout all the discussions, there's data collection ongoing. We collect data for 181 districts since 2000, and as this is ongoing, it influences the discussion, it influences the assumptions in the model of the model calibration. So it's an iterative and ongoing process. So taking all the data and the history, we are interested in the future interventions, and as mentioned, as they're described in the National Malaria Strategic Plan. So we are considering case management as an intervention, assuming that the effective treatment coverage would increase to 85%, but then stays constant between 2017 and 2020. Next intervention we are considering is mass distribution of insecticide-treated nets, either as a mass campaign, assuming to be in 2019, or as continuous distribution every year at a lower coverage. This would reflect the distribution through school nets, through schools, or to antenatal clinics. Further, we include indoor residual spraying in the model, assuming a high coverage at 90%, and varying insecticides, so actelic and benzyl carb in rotation. Then we include also larvaciding, but here larvaciding, the impact of larvaciding was not parameterized to field data, so we have for this one a theoretical approach, assuming that 80% of emerging larvae would be killed. But still we would be interested in what would this predict us. And then, although not mentioned in the National Malaria Strategic Plan, we also include mass drug administration at high coverage. This gives us 48 unique scenarios to look at. So just briefly to modeling process to combine how we combine the data and the future interventions. The first step is to reproduce the historical trend and to estimate parameters. As mentioned before, we needed to estimate the entomological inoculation rate with the prevalence, as this was not available. So here in yellow you can see the simulated prevalence, and in blue the model predictions between 2000 and 2012, between 2003 and 2012. And here you will recognize that they're not quite aligned as expected, but this has a simple reason that we took the ITN coverage predicted from Malaria Atlas project, and we were restricted in the parameters we could use for fitting. So I should say here it's more accounting for the history and then reproducing the baseline. So this is the baseline here in 2016. We wanted to make sure that we fit to the malaria indicator survey in 2016, and that fits quite well. After having this baseline and accounting for the historical trend, we simulate future interventions and generate predictions. So here you can see the 48 combinations, the prevalence from 2016 to 2020, and for simplicity it's colored by ITN coverage. And here I already move on to some results as it's so obvious. If you remove ITNs, there's a high rebound. However, depending on the additional interventions, the rebound is less high. This is also an iterative process, and once this is finished, the next step would be to select the best intervention and to draw a recommendation. However, this is not part of this presentation, as it's a whole chapter in its own. So now coming to the results, and starting with the fitted ER. This is the entomological inoculation rate per district in Tanzania, and this nicely reflects the seasonal pattern as we have seen previously, with higher ER around the lake zone and in the southern zones. Here you can see the baseline prevalence. On the left is the model predictions from the malaria indicator survey. Here I should mention it's called predictions. It's not to be confused with the simulation, as it's geospatial modeling to generate prevalence estimate at district level. And on the right, you can see the simulated prevalence from the open malaria model. And the overall pattern is nicely reproduced. However, in low transmission districts, there's some underestimation in the prevalence. So moving on from this baseline prevalence, what would be the impact of future interventions? And here, for simplicity, I just mapped the impact of single interventions for each district in Tanzania. And we're not going too much into detail here, but I just want to highlight some patterns. So the first one is called the base, as this is the counterfactual for us when assessing the impact of the interventions. It's when the treatment coverage is maintained, but no additional interventions deployed. And you can see that there's a rebound in prevalence in almost each district. Then the next one, case management, is what would happen if you would treat 58% of all cases. And you can see that the prevalence still increases again, but not as much as if you would just maintain the current level. Then on the next, there's two ITN maps with the campaign and the ITN continuous distribution. You can see that this drastically reduces the prevalence, although not in each district. Especially the mass campaign seems to have less impact in the southern zones. And a reason for this could be as the southern zones had continuous distribution at lower coverage, and it might be that the rebound was so high that the mass campaign could not overcome this. Indoor residual spraying has also high impact and reduces the prevalence in most districts to below 1%, although not in all districts. So in some districts, additional interventions might be needed, especially in the north and the south. Then coming to the more theoretical interventions included larviciding here. So if you would kill 80% of all emerging larvae, this has not much impact on the prevalence as a rebound almost everywhere. And then for mass campaign, it's the same. Although in low transmission areas, it maintains the current prevalence. But of course, as said before, interventions are not deployed at a national, are not deployed at once and not alone. So we were interested in looking at the interventions as planned in the National Malaria Strategic Plan, and this would be continuing IRS in the lake zone, scaling up school net distribution in the south and also in the lake zone, and to have a mass campaign at the low transmission areas. And on top of this, in urban areas to include larviciding. So we looked at what would happen to the prevalence in the next few years, and this is how it looks like. It looks quite encouraging, although not all districts reached the target of a prevalence lower than 1%. With this, I would like to summarize. So we developed a flexible model adjusted to country data to provide support to NMCPs in their decision making. And in many districts, a prevalence of lower than 1% could be reached, however, not everywhere. And this also only when assuming that a high coverage could be reached of 80%. And here just plotted two maps. If that could not be reached, you see on the right, if the coverage would vary, there would be a totally different map. And this would affect the interpretation and recommendations. So careful sensitivity analysis is important at this point. And we also saw on the maps that none of the interventions alone could reach the target of a prevalence of 1%. So additional interventions are needed. And to point out, entomological assumptions are critical in the model and critical for the interpretation of the model. So currently there's entomological surveillance survey ongoing in Tanzania, and soon we will have updated data and will be able to update the model with this. The strength of the model, as already mentioned somehow, it's that we use country-specific data and we account for the history of the interventions in each district. So to look forward, the next step will be to update the model and with the new data and with new questions raised by the program, but also to include some cost-effectiveness analysis and to identify pattern for intervention stratification, which could look like on the plot below, taken from the National Malaria Control Program. Yeah. And this, I would like to thank the team involved in this modeling, especially the colleagues from the National Malaria Control Program, and especially the team at Swiss TPH. Thank you.
We have time for one or two questions.
I have one question. So on the sort of final slides, you looked at, say, the sort of varying uptake of, say, ITN coverage. And
yeah.
So do you have an idea of, say, perhaps, say, the reported distribution of bed nets versus the actual sort of use of those bed nets that are actually being distributed to the areas? So an idea of, if it states still that there's, currently say 60% ITN distribution in that admin region, how well that's actually covering your admin regions or anything like that? Have you gained any of that information from the NMCP for Tanzania?
So if I understand your question right, if the reported ITN coverage is the same as the actual coverage?
Yeah.
I think this is a good question, but difficult to assess as we are using data from malaria indicator surveys, and there we have the data, the people report.
Thanks for that nice presentation. Just comparing this with real impact data historically and contemporarily with IRS and bednets, is it possible that these simulations are a little bit on the optimistic side?
I'm sorry, can you repeat your question?
These projections don't look entirely compatible with what we've seen with IRS and bednets in Tanzania, either in recent history or going back as far as Para-Taveta. So is it possible that these projections are a little bit optimistic?
Yeah, sure. I should have mentioned that we do not assume resistance against IRS. So this might be that we overestimate the impact of IRS, if that answers your question.
Yeah, one more.
Last question. Yeah.
This is more a comment on this particular session. As you can tell, if you've been sitting here for most of it, it's extremely heterogeneous. People doing single-cell genomics, modeling, et cetera, et cetera. And it seemed that this came from the abstracts that we got that were in something called other, when you actually put your abstract in. And I wonder, and this, you can have input on this, whether there should be a sort of technology section, which might be useful. Even just thinking what Oliver had to say about how you estimate the level of transmission, and what Manuela just said, you guys should talk to each other. So I wonder, the hope was that one would stimulate these kinds of cross discussions among people using sometimes quite different kinds of techniques, but asking similar questions. So if you think that's the case, we're thinking of having a sort of technology section that would help people who've just put their abstract into other, and we're trying to then figure out where to put them.
Okay, well, with that, we'll close the section. Thank you for coming.